All right, so this is going to be from chapter 40, and we did the osmo regulation a little bit. So we want to talk a little bit more about temperature. Um, and so we're gonna talk about regulating temperature, the homeostasis. And so this will be the beginning of 3 lectures, I believe. Okay, so what we want to do is take a look. So here we got a fox maintaining body heat in the snow. So we want to talk about different types of organisms and how they do things like this. All right, so first of all, homeostasis means to kind of keep a balance. And so here we got body temperature versus ambient temperature. So we have some terms, regulators and conformers. So the river otter would be considered a temperature regulator because it, like us, has a constant body temperature. You know, ours is 100. I'm sorry, it should be 98.6. Hopefully it's not over 100. Yeah, more or less. And then so here, river otter, I'm not sure, you know, what's their body temperature is maybe a little higher than ours. But again, they're regulated. So the ambient or environmental temperature, if it's, you know, here they're showing 5 degrees Celsius or all the way up to 40 degrees Celsius. Their internal temperature is pretty close to the same. You know, you can see it drops a little bit as it gets colder, a little harder to keep its temperature. But you notice it stops on both ends. Those are extreme conditions that would probably, for any length of time, would kill that animal. On the bottom, we have what's called a conformer, and that would be a largemouth bass. And what you're seeing is its body temperature is pretty close to what the environmental temperature is. They do not control it much. And so that would be called a conformer. So your regulators are ones that are trying to keep a basic body temperature, whereas a conformer is just doing what the environment is doing. So we're going to look at some of these terms. Homeostasis, what they're finding out has some variances. And we have these daily cycles, circadian rhythms, and what they're coming up with is the new data on this is really these rhythms that are kind of deciding homeostasis. And so here they have a picture of a clock, and it's kind of cool: lowest heart rate, highest risk of heart attacks, fastest reaction time, greatest muscle strength. So they're showing you different things. And this one is based on a person who gets up early, eats at noon for lunch, and sleeps at night. You know, yours will vary depending on when you do all these things and how much sleep and all that. But anyway, so just want you to know that this internal clock, this circadian clock inside us, kind of regulates our homeostasis. All right, let's talk about thermoregulation, and I want to give you 4 terms, and they are different, and this is where people get screwed up. There's ectotherm, endotherm, poikilotherm, and homeotherm. So an ectotherm is one that gets its body temperature from the environment, the ambient temperature. And that would be things like lizards and turtles, insects are typically ectotherms for the most part. Amphibians, fish, ectotherms. Endotherms, on the other hand, the body temperature comes from metabolism, and that's typically birds and mammals. And again, there are some reptiles that can do that a little bit, and maybe even some fish, but for the most part, endotherms are really birds and mammals. All right, this is where it gets confusing. Poikilotherms are organisms that their body temperature fluctuates greatly. And so it's hot, their metabolism is high. If it's low, their metabolism, I mean, if it's cold, their metabolism is low. So fluctuations, poikilotherm. Homeotherm then means they have a constant body temperature. Okay, so here's what I'm going to let you know. Most ectotherms are poikilotherms, and most endotherms are homeotherms. But again, there are a lot of variations in this, and I just want you to realize that. There is a lizard they found that is pretty homeothermic, and it's doing it mostly by behavior. They had some sensors they put inside them, watched their body temperature, really didn't fluctuate much, and they thought there was some problem with the thermometers, the little sensors. And it turned out it was just all behavioral. The animal would burrow under the ground, and their body temperature was pretty consistent. All right, so here again, here's the ectotherm and here's the endotherm. So you can see, again, toward the cold areas, the temperature will drop a little. It's a little hard for maybe the mammal to keep its body temperature up, but you can see the snake is pretty even with the body. And then we got a mouse being eaten, and that there's no body temperature at this point. Thing is dead. All right, so let's talk about thermoregulation. And there's 4 words on here I want you to know. And we'll end this little video on that. So radiation, evaporation, convection, and conduction. So I want you to know there are 4 ways to gain and or lose heat. And what I want you to know is their definitions, and then whether you can gain heat that way or lose heat that way. Okay, so we'll start with radiation. This is actually the transfer of heat due to electromagnetic waves. You can gain heat this way. And if you don't believe me, go stand in the sun. That is the ultimate electromagnetic wave. And you will pick up heat this way. It turns out we also radiate heat off. Your body gives off heat. And that is also, so we lose heat this way. And you've seen this. If you're ever in a group of people and they're real close together, the rooms warm up, and that is from radiation. It also starts to smell, but that's a whole different thing. All right, the second one we're going to talk about on the top there is evaporation. And this one's a little bit different. This is the loss of heat due basically changing a liquid into a gas, which we'll talk about a little bit more. But if you notice, this you can only lose heat this way. That's the one that you can only lose heat. You cannot gain heat from evaporation. So we'll talk about it. We do it sweating and panting and things like that. The one on the bottom left is convection. And convection is where you move it's a transfer of heat by moving one substance across another, such as wind or water, like a current. You can gain heat this way. If you don't believe me, we call those heaters. Basically, you have something that you warm up, and then you blow air across that, which warms up. And you can cool off this way. We call those air conditioners. You have something that generates cool air, and then you blow that across. So like a convection oven, I don't know if you've heard of those before. It's just a typical oven, basically, with a fan in it. And it's pushing the heat around what you're cooking and makes it cook a little bit quicker and a little more evenly. And then the last one is conduction. You can gain and or lose heat this way. And so again, this is heat transfer due to direct contact. And so this lizard laying on the rock is a good example of conduction. If the rock is hot, it's gaining heat. As a kid, we used to, you come out of the water, you couldn't go in the house because you're wet, and we used to lay on the hot sidewalk. That was a way to gain heat. And when that area got cool, you jump and find a new spot on the sidewalk. The same is true. If you lean up against a cold wall or something, you will give off heat to that, and you will lose heat. Warm the wall. Okay, so know those 4.